Hello everyone, I'm Vishesh Vaibhav, your Google Developer Student Club's lead. Welcome back to another video where we are ready to talk about polynomial regression. So the previous videos were focused on two types of regression. Firstly, simple linear regression, and secondly, multiple linear regression. Now we understood what both of them really meant and we had a great time understanding it. So the next step is to understand a different type of regression. As I promised, there would be a few videos in that series of regression we are currently doing. So the next step is doing polynomial regression. So what is polynomial regression? I'm using the same example that I have used previously in our examples of multiple linear regression and simple linear regression. So I'm just going to refer that again. So in simple linear regression, there is one dependent variable and there is one independent variable. But if you are watching this video for the first time and you do not know what these terms really mean, then you should go back and refer to our previous videos on data pre-processing and all the previous videos in the regression playlist. So moving forward, so in simple linear regression, we have one dependent variable and one independent variable. So this is what we did. In the multiple linear regression, we have one dependent variable and many independent variable. Okay. And now if we are coming to polynomial regression, well, it's just a extended case of simple linear regression and multiple regression where it has one dependent variable and one independent variable, just like simple linear regression, but it is non-linear, which means that how does a linear equation looks? Well, a linear equation looks something like this, right? This is what a linear equation looks like. And same goes for a multiple one. A multiple linear equation looks like this, right? This is what we have done before in our previous videos. Now, now that we have to talk about polynomial regression, let us see what that means. Now, if you see here, this is a polynomial equation, right? So if you know what a polynomial is, we definitely know that anything which has a power or which is in a polynomial form, it is a polynomial equation. Same goes here. We have it's called polynomial because the equation which is formed here is a polynomial equation. I'm going to explain what this equation really means in a moment. But yes, this is what it really is, right? It is polynomial. Now, coming back to our example, that it is non-linear. It means that if you look at different uh, the different graphs of simple linear regression and multiple linear regression, you would see that the linear regression has a graph like this, which has a straight line and something like this exactly. But same goes for multiple linear regression. It has different variables, right? And now coming back to polynomial regression, it is something like this, where the regression model that we are building aims to cover and predict the scatter plot in the most efficient way. So if you look at this, this is what it means. So if we have a plot here, if we have a scatter plot like this, and if we had to, I'll just do this. So if we had to predict through a linear regression model, the graph would look something like this. But as you can see, some points are close to our prediction, but some are very far, which is not an efficient prediction. Because of which, this regression model is not suitable always. So because now you might ask that why this is called polynomial linear regression. So this is actually polynomial regression, but is a part of linear regression. It is linear because we still have this. So if you remember what was B0, well, it was nothing but the constant. So I'm going to explain the equation first. So it is the constant, and then we have the B1, which was the slope coefficient, and X1 and X1 here was the independent variable. Now, you see a difference here, right? We have B2, which is again same as multiple linear regression, that there is a new slope coefficient, which is fine because we can always have a different value for the coefficient, but that's okay. But what is x squared now? Now, if you look, at multiple linear regression, we had something called x2, right? Which meant the another independent variable. So this was weather, x2 was temperature, and fertilizer was x3, right? This is what was there. But now, as you can see, we are only using x1 here. Why? Because we talked about this. There is only one dependent variable and one independent variable. So we are using only one independent variable in this case, right? So if you look at this, we are always using x1, x1, x1 here. But here's the difference. What we are doing is we are taking it to the nth power. What does that mean is that here, if you look at it, it's b2 x square x1. So x1 squared, x1 cubed, x1 to the n power. So this is how it goes. So if you look at it in this way, we are always using the same independent variable here. But what we are doing is it's xn, not x4. So what we are doing is we are just giving it a we're just giving it a power. Why is that necessary? Well, because it's polynomial regression, and this is how we'll calculate our predictions. This is how we make sure the slope goes this way, and this is how we make sure that as the power increases, our prediction uh, accuracy increases. So this is what we are going to discuss here in polynomial regression. So to talk about this, we are going to talk about some firstly, we'll definitely get on to the practical, but first we need to discuss something about the data set that we are going to use. So it's a tricky data set, but we are going to understand it, and then after understanding it, we're going to come back. So let us do that now. All right. So what I have done is I've just copied 1 second. I've just copied the data set that we are going to work on. So this is actually a real life data set and you're going to enjoy working on this. But before we start working out on this data set, we need to understand what this data set really means. So we are going to use this type of regression as a type of case study where we are going to understand each and every aspect and we're going to use it in this way. All right. So I want you to do something. I want you to ignore this in the practical that we'll be doing. So the first column is the position, which is just for our understanding. And what we are mainly working with will be the level and the salary. So let us understand the case study now. All right. So the case study is that you are an interviewer in a company and you want to hire somebody, okay, and that person that you want to hire has gone through the interview process, and after the interview process we always discuss something which is the salary. So now comes the question, how much salary are you expecting? So you ask the interviewee that how much is are they expecting, expectation, to which they reply that they are expecting for example they are expecting 1,60,000 or 160,000. Okay, this is what they are expecting. Now this is their expectation, 1,60,000 a month or 1,60,000 a year. That's your interpretation, depends on rupees or dollars. So now this is what they're expecting. Now you ask them that, okay, you are expecting 1,60,000, how do you come at this conclusion? How do you ask this? Like, do you have anything to back this up? So he says that in the previous company that I worked, the previous company, I got this much. My previous company salary was 1,60,000. So this is what they tell you. So you're like, okay, and you send them home. Now you come back, and what you do is you open up your laptop and go to the company they search up the company they were working on. So you check their resume and you got that okay, they were working for company A, B, and C. So this is the ABC company they were working for. Now you go to Glassdoor or these websites which give you the company insights, the salary insights of the company. so that how much salary they are getting for a for example, if it's Google, how much does a software engineer at Google earn? You can find that easily on a website like Glassdoor. So that is what you do. Go on Glassdoor and research the company. Now, after researching, this is what you get. You get the you get this data. All right. So what is this data? Now, this data is the uh, ABC's company salary trend, right? This is the ABC company salary trend, that this is how much they get. So this is the position. A business analyst is on the level one, which now the what are these levels? These levels are which they are on the salary level. So a level one business analyst, for example, a business analyst who is on level one will get a salary of 45,000. So what we are interested here in, a business analyst gets 45,000, and which level it is, it's level one. So it does not mean that business analyst of level two would get this. No, it's just that business analysts are on level one and the salary is 45,000. A junior consultant is on level two and the salary is 50. Same goes for senior consultant, and so on and so forth. Now, what is the salary that they gave us? He gave us 1,60,000. Now, what you do is you go back to the LinkedIn profile of the person who you interviewed, and you found out that he is working as a region manager. So he was working as a region manager, and he has been working as a region manager in that company, in the previous company, in the company ABC, for quite some time. So now you would look at this data, and you would find that okay, the region manager is on level 6 and he's earning around 1,50,000. So that's the salary that they are getting. And if he has been on that position for some time, he might have been closer to this position, because obviously if there's a promotion, he would get around this much. But the salary he told you was 1,60,000, which is almost close. So the predictions that we'll be making is between level 6 and level 7. So now when we'll be making the predictions to our model, we'll be predicting for a level of 6.5. Now, in this, which is the independent variable and the dependent variable, I want you to pause the video and tell me. All right. So the independent variable here is the level, and the salary is our dependent variable. And then what about this one? Why is the position not considered? So for a simple reason is that, as I firstly, the first reason, for the simple reason, is that there is only one dependent variable and one independent variable. Now what you can do is you can convert this into using one hot encoding. You can convert this into a different thing, but that won't give you any concrete idea to work on. So the reason is, we know that a business analyst is on level 1 and he's getting a salary of 45,000. So this data is actually redundant. We do not need it. If we know that a one level means a business analyst and he's getting 45,000, so it is already giving us the data we need. So this is what we need. And when we'll be building our model, we'll be making sure that we do not include this. So this will not be included in our predictions. All right. We'll only be using the level and the salary. And this 6.5 means nothing but the predictions. For this case study, we'll be making the predictions on 6.5. So why is that? Well, you know the answer again, because he told us that he was earning 1,60,000 and this is what he's expecting. Now, we went to his LinkedIn profile and we found out that he has been region manager for quite some time. And because he has been that on that position for quite some time, he can become a partner soon. And then if he becomes a partner, he would be earning 2 lakh. But right now he's earning 1,60,000, which means, is he expecting the right salary or not? So this model would ultimately give us a model which we would like to, if we wanted to predict the salary of a person who is working on this for quite some time. For example, if the person is on level 8, if what how much he should expect based on this. So this is what polynomial regression really is. It's helping us do that. Now how does polynomial comes up? Well, what we are going to do is we are going to take this data set, and what we are going to do is we are going to level it up. Sorry about this, we are going to square it up. square, or better put, we are going to exponent this exponential, we are going to put it in exponential form, which means that we're going to use the same x1 variable every time, which is the level, but we are going to use the degree. We are going to increase the degree, 2, 3, and 4. We're just going to do that. Why? Because this is what the question demands from us. That is what we want to take out from this, right? We want to take out, we have used the salary trend, and using the levels, we want to predict the salary of the person. We want to check if for a particular level, that is 6.5, how much should the person be getting, right? This is what the polynomial regression asks from us, and this is what we are going to do in the practical now. So moving on to the practical. All right, so now moving on to the practical. So the first thing that I need you to do is that you should understand what this means, okay? Because this is really important. So once you analyze the data set that we are working on, everything becomes quite easy for you. So now that you have analyzed everything, you know what the data set means, you will be able to do a lot more on it, okay? So we have already discussed what the data set means, but if you want to just go ahead, pause the video and analyze the data set again, you can do that. This is written cleanly, not in my bad handwriting, so that helps, right? Okay, now we are going to come to our part where we are going to discuss polynomial regression. Okay, okay. So the first thing that we always do is we're going to go back to our data preprocessing toolkit, and what we are going to do is we are going to import the libraries. But before that, we are going to add a text file or a text column, and then we are going to write importing the libraries. All right, so we are now importing the libraries. It's done. So meanwhile, we'll add a new text file, and then we are going to import the dataset. And it's connecting now. Okay, it's connected. So now we'll be importing the dataset. So let's import that. Okay, now we have imported the dataset as well. So before importing, we need to upload the file. I'll do that. I've uploaded it. I will copy the path and then I'll paste it here. You'll find this data set in the description box. Now, let me just bring this data here. Now, remember what we talked about. We do not want to mess with the position because this is really redundant in our case. We do not need this. We only need the level and the salary. So we are going to mess with the values of the independent variable or the indexes of the independent variable and the dependent variable. Now I want you to pause the video and tell me that in the independent variable, what do we do? What changes do we make here to just access only the level and not the position? Because this line here accesses everything except the last one, which means position and the level. So what do we add here or remove in order to get only the level? But just make sure, there are many ways to do this, but just make sure this stays because this will be your toolkit. So anything you're making, there should be only the minimal change that you should be making. So what's the thing you should be putting here? All right. So in order to do this, the best and efficient way, I think, with there can be a few ways, but the best efficient way, I think, is just using the normal indexing. So 0 and then 1. So we want to access the index 1 column. So we're just going to add 1 here. So what this essentially means is it's going to access everything from the first. So it's going to omit the 0th index. It's going to access the first one and everything from the first until the salary part. So it's going to exclude the salary column. Okay, so we're going to come back here. And the dependent variable is always going to be the same, the last one. So salary is going to be our dependent variable. So that's going to be the same. Okay, I'm going to run this now. Okay, so the next thing, if you come back to the data preprocessing toolkit, it's taking care of missing data. We know there is no missing data, so that's redundant. Now encoding categorical data. Now because we can use this, but because in our case this is redundant, we do not need to encode anything because we are not using this at all, then there's no need of it, right? Okay, what's the next thing? Splitting the data into training set and test set. Now you can do that. You can definitely split this data into training set and test set. But because there are only 10 entries, I do not see the need to split this because if we are just using the whole, we are making the prediction on the whole data set, we are going to get better results. Why? Because again, we are not defeating the purpose of training the data, splitting the data set into training set and test set, because that is important when we are working with bigger data sets and we want to get some predictions out of it. Obviously, these are also making some predictions, but here we do not want it because it's not necessary, because firstly there are only 10 entries and we can work with this and we can get the predictions on the basis of this using some of the functions of the sklearn library. And secondly, if we were to split this, the predictions on the test set would be a bit small because out of 10 only 2 of them would be used for a test set, so that's not enough for making a prediction. So that is why we are not using the training, we're not including the splitting the data set into training set and test set part, and feature scaling is obviously not required. So okay, I will close this up. So what's the next thing that we want to do? Well, if you look at our previous two videos, we always train the model, so we will be training the model now. So now uh I want to ask you something. I told you that polynomial regression was a special case of the multiple linear regression and the simple linear regression. So in order to do this, we'll definitely be performing polynomial regression. But to compare that why are we using polynomial regression, we are first going to implement, because see, linear regression also has one dependent variable and one independent variable. So what we are going to do right now is we are going to perform linear regression first, train the same way we trained our linear regression model. We're going to do that, and then again train the same model in a polynomial regression model part, so where we can deduce from the fact that okay, what's the difference that we are getting, right? This is what we need to do now. All right, so firstly what we'll be doing is we'll be training the linear regression model on the whole data set. We're not uh, splitting, so we are training it on the whole data set. Just going to delete this. All right. So we're training the linear regression model on the whole data set. So I'll just go back here, and because we have done this a few times, so now I remember. I hope you remember that too, but it's not necessary. You should remember. You can always search which sklearn library is used for training simple regression model, and it'll tell you to always go for the documentation link. It's linear model and linear regression. That's what we want to do here. So that is what we'll do. All right. Now that we have done that, after importing a class, what's the next thing that we do? What's the next thing that we do? We create an object. So that is what we are going to do. But here's the thing. We are going to call it linear regression. And then we are going to call the class, and then we are going to create an object of the class which is linear regression. And what do we do to train the model? Fit, right? And what are we going to provide? This x and y, because we do not have any x train or y train now. We only have x and y because we did not split it into training test and test set. Now what was x and what was y? Well, x was the independent variable and y was the dependent variable. Okay, now we are going to run this. Now it has given us some linear regression models. So now this linear regression object has our trained linear regression model. Okay. Now, that was the next thing that we need to do. Now we have trained it on the linear regression model. Now we need to train that on the polynomial regression model. So let's do that because that was our initial intuition, right? Training the polynomial regression model. So I'm just going to add a text here. All right. Okay. Okay. So let's do that. So let us check which SQL library is used for training polynomial regression model. Okay. So this is the scikit-learn official website, documentation website. This is what I should be looking for. Okay. So from sklearn pre-processing, we are looking for polynomial features. All right. Let us do that. All right. Everything is good. So autocomplete also helps us there. Now, after importing a class, what do? We create a object, polynomial regression. All right. So let us check what does this take. It takes a degree, right? Remember what we talked about? Now, I want you to do something. I want you to read what this means. This actually, read this. And now this would make you understand what we talked about, right? Now, the thing is that we wanted to use the same independent variable but with degrees. Remember x square, x cube, that is what we did, right? So we are going to use the same thing. Now, firstly, we will use the degree 2 just for our test purpose, but well, then we'll train it again. We'll use the degree 3 and 4 just to check our effectiveness of the model. Okay. So polynomial features, and this will not be 2, this will be degree is equals to 2. Okay. As you can check, this is what this polynomial features needs from us. See, degree 2. Now we have given it this. What's the next thing that we need to do? Now, after giving it this, we need to, let's check. So it has a fit function as well, but it also has a fit transform function. So what you can do is you can firstly fit and then transform, because the transform is needed here. Because see, the reason is we fit and we just train it and then transform it again if we want to. But usually we do not use transform in the case of our linear regression because it's already trained and then we use the predict part. But here in polynomial regression, we need to fit and transform it. So either you can fit first and then transform it, or you can use fit transform in total. So let us do that. We are going to use fit transform. So then we are going to use our polynomial regression dot fit transform. All right. And then we are going to pass in x because that is what we want to transform right now. So what was x? The independent variable. Do we want to give degree 2 to all of our dependent variables, which means the salaries? No, we do not want that. We only want to do that with our independent variables because we are only going to fit trans. That is why we are only going to fit transform x. All right. Now, this would return us an array or a matrix of features, which we are going to store again in a variable so that we can access it whenever we want. So let us call it x poly. All right, sounds good. So I'll explain what I did again. So this is what it was. It was polynomial regression, and it was using fit transform method. But what we did was we used the fit transform method and we applied it on x, our independent variable, and then we stored it in x poly. All right. So this is what we did here. All right. So now that this is done, what's the next thing that we need to do? Well, the next thing is again using a linear regression model. Because again, polynomial regression is a special case of linear regression. So we are going to use this degree, that degreed version, which means firstly we use the linear regression to on the original level. So this was the original level. Now what we have done is we have given a degree 2 to all the levels. That means remember the equation now, x2, x2 1, x cube 1, and x4 1, something like that. So we have done that now. Now we have given it a degree, but now we need to use the linear regression on this exponential, is this new formula. That is what we want to do now. We want to use that linear regression model on this now. So I'm going to create a variable again. So let us call it linear regression 2. Sounds good? Okay. Linear regression 2. Now what we'll do is we have already imported the class, so we'll just call the linear regression model here, and we just import the class, sorry. And after doing that, we will use this linear regression. And what do we do to train a linear regression model? We fit, right? This is what we do. We fit. And what are we going to pass here? Well, in the previous case, when we were using the original level values, we were using x. Now we want to use the value of x where everything has a degree, every level has a degree of 2. So which one are we using? We are using x poly now. Why x poly? Because this variable has the all the data of levels with a degree 2. So this is why x poly, and y would be the same, salaries. Okay. And let us run this and see if we get any errors. No. So the linear regression model is also trained. So now you would ask that why, how is it different from polynomial regression, how is it different? Because we ultimately are doing linear regression. So as I told you, polynomial regression is a polynomial linear regression. The only difference is that we are using the different values of x. So x is x square or x cube. That is what we are doing now. So let us just visualize it now. So we are going to visualize now the linear regression model first. So this is ultimately a polynomial regression model, but this is the linear regression model that we have trained here has a degree 2. Okay. I'll also demonstrate this in a way where you see the difference with the formulas. So what I'll do is, okay, let me just do it here. So the formula for this would be, first let me write the formula for this. So the formula for this would be y is equals to p0. Let me just give it a comment. P0 plus b1x1 plus, that's all. So we only have one variable. So this would be v1x1. Okay. This is the normal linear regression model. Now coming to the polynomial regression, this would be the same, but now we'll have b2 x square 2 x square b2 x square 1. So this would actually be x1 square if you put it that way, and this would just go on plus b3 x1 cube, and this would go on for n times. Okay. So this would be bn x to the power n. So this is actually exponential. Okay. So this is what the difference between the formula is. All right. So this is a polynomial regression model and this is a linear regression model. So first we are going to visualize the linear regression model, and we have done that before in when we were building our linear regression model. So we're going to do that now. So what I'm going to do is I'm just going to pause this video. I'm just going to bring my linear regression model in front of you and just going to copy the same visualization that we did with the linear regression model. So it will make a task. All right. So I've just brought my the linear regression notebook that we worked on. All right. And we're just going to copy all of this because we were visualizing the training set results here, right? So that's the same. We were visualizing the the linear regression model, right? So we're gonna come back here and I'm just going to paste it here. All right. So what are the values that we need to change here? I want you to pause the video and do it yourself and then just follow along. Okay. So X and Y train would become X and Y. The color should be the same. This would again, because there is no X train, this would be X. Now this X train would definitely become X. The color would be blue. So this was salary versus experience. Now this would be truth or lie. Why truth or lie? Because remember our case study. What was our case study telling us? We wanted to know if the person who asked for 1,60,000 was he telling the truth or was he telling the lie? Now, if you don't understand what this means, I just want you to go back and look at our theory part where you will understand which case study that we are doing. Okay, so this is for linear regression. Now, this regressor was the object of the thing that we made in our simple linear regression model. Let us go back and check the object of the linear regression. It is linear reg. That is what I am going to do. Linear reg. Okay, everything looks good. It's going to be not salary but position level, and y level definitely would be salary. So let us check now. Everything else looks good. Just a plt dot show. All right. Everything else looks good. Okay. No errors. No. So this is our linear regression model. Now look at this and look at the linear regression model that we built here. There is a difference, right? Because in this linear regression model, the predictions are really good. That means that it is touching almost every point. So the remember the ordinary least squares. So here the ordinary least squares have the minimized scores, which means this model is good, right? But if we come back to the model that we built in polynomial regression, this is a bit different because as you can see, even if you do not know anything about ordinary least squares, this model is different. This model doesn't look right, right? Now, what do we do about this? Well, this was a linear regression model for the same thing that we built. Now what we are going to do is we are going to visualize the polynomial regression model and see if anything changes, right? Let's do that. So we are going to add a text box here. All right. So to visualize this, I'll just copy this because there are some changes that we'll make in this. Otherwise, it'll all be the same. Now, X and Y, everything else. Let us make this now. Okay, so X and Y will be the same. Now in plt.plot, what are we looking to plot now? Which means which line are we looking to plot? So back there we were using the linear regression model, but now we are visualizing the polynomial regression model, right? So this would definitely change. So this would definitely change. So I am going to do this. Now what would it contain? So let me go back to the polynomial regression model. It is using polynomial regression model is using linear reg2 as our object. So that is what I'm going to write. Linear reg2. And obviously we're going to use the predict function. But are we just going to pass in x here? What do you think? The reason is no. The answer is no. We are definitely not going to do that. The reason is because our exponential, so the levels that we were comparing here were the original position levels 2, 4, 6, 8, and 10. Now the position levels that we want is the exponential position levels with the degree 2, right? This is what we need now. So what we need to add here now, we need to add this, the fit transform for the degree x. This is what we need to add here now. So that is what we'll do. We'll copy this, we'll paste it here. So what are we going to predict? This is what we are going to predict. So we will be plotting x. On the x axis will have that, and for the y axis we'll be having the linear regression dot predict, because that is what we are predicting, same as this. But just than passing x, what we are doing is we are passing the exponential form of x, right? That is what we are doing here. Okay, now what we'll do is we'll just change this to polynomial regression, and we'll paste this. Okay, let's see what we get. All right, so this prediction is a bit better, right? This is actually a bit better, but still some of the points, only two of the points are really good. Some are still distant and some are still distant, and this one is very distant. So it's a good model, but not a great model. So what do we do about it? Anything that we can do about it? Well, remember I talked about the degree. So this is what, now if you refer back to the formula that we did, y0 b1 x1, so we have performed this only on this formula. We haven't used this, or for that matter, we haven't used the other degree as well. So as we continue increasing the degree, the the accuracy of the model would also increase. So what we are going to do here is that we're just going to make this degree 4, and we are going to run this cell again, and this would run again. This would, although make no difference, it would be the same because it was the linear regression model. But now if we are running this again, this would make a difference, as now you can see the lines that are of the polynomial regression prediction line is now matching most of it. Now if you want a like even a good prediction than this, then you can always increase the degree and you can get this line even closer. But I guess this is fine for us. This is a good model, and the predictions are even close to to the real values. So even if you do not know what these values are, these are the real values, and the blue line is the predicted line. And same goes here. The red dots are the original values, and the blue line is the predicted line. Okay, this is what it was. Now let us answer the question to our case study. Was the person who was asking us the question, was the person who was asking us the question that I am getting 1,60,000 or 160,000, am I getting the right salary? So we wanted to check if the person was telling a truth or a lie, if he really deserves the 1,60,000 or he was just making that up. So based on the data of the previous company, remember we came on a conclusion. So I'm going to show that to you again. Sorry, so that's not coming up, but if you remember, that's what we did. So if you remember, what we did was we came at a, if you just scroll back to the video, you'll just go back and see that we came at a point where the position level of what he was asking was between 6 and 7. So we wanted to predict that if he has been working for some time, obviously his position level will be 6.5. So if his position level is 6.5, how much does he deserve? So that is what we are going to do. We are going to predict the values, the predict a new salary that he should be getting with the linear regression and the polynomial regression. So let us do that now. So predicting the salary salary with linear regression. So let's salary with linear regression. Okay, so we are predicting the salary with linear regression now. Okay, let us do this. And while predicting the salary, we have always, in the previous two regression models, we have done this. So we're going to do that again. So which is the object of the linear regression? It's reg. Okay, so linear reg dot predict. And if you remember, it always takes a 2D array. So 1D array, 2D array, and the value that we want to predict, which is 6.5. Why? Because this is the possession level we are looking for as of now, because that is what the person is in right now. It's giving us 3,30,378. The person was asking us 1,60,000, and this model is giving us this. Is it correct? No, it's not, because that is what we wanted to predict. Now, if we use the linear regression model to predict the person's salaries, our expected salary would be very much high, and we would be overcompensating the person, which is wrong. Which is why we'll be using the polynomial regression to predict now. All right, let us do that. And why is that? Because we definitely predicted both of them, and we know which one was correct. I'll show you. So if we come back, the linear regression model was a blatant lie. We could not trust that. But a polynomial regression, well, we can definitely trust this. So that is what we are going to do now. Linear regression dot linear regression 2, because that'll be polynomial. So linear regression 2 dot predict. All right. Now, okay, so here's the thing. Now, the thing is that we have to provide the value of x, the position level. But the position level should be of the degree which we have made the prediction for, right? So it should be of the degree which we want to do it, because this position level was the original projection level. We did not make any change to the position level 1, 2, 3, 4, 5, which we did not make any changes to the position level when we were working with the linear regression model. But with polynomial regression model, what we did was we gave the polynomial regression models the independent variable, a degree of 4. So that is what we are going to do again. We cannot just pass an x there. We need to first give the x, the value that we are going to pass in, the degree of the polynomial regression that we have trained it on, right? Because that is necessary. So if we just pass in 6.5 here, it won't give us the results. Why? Remember, this predict method always takes a 2D array. So just we're going to do that. Double square brackets. This would make it a one square bracket would make it a 1D array, and two square brackets would make it a 2D array. We have discussed this in our previous videos. Alright, so now if I run this, let us see what it gives us. 1,58,862. Now, if the person demanded us 1,60,000, and this is giving us around 1,59,000, it's a good prediction. So what he's asking is actually correct. So we are going to hire that person. So this is actually a truth. So as you can see how polynomial regression model helped us make this prediction, and why was it necessary in order to make these predictions. So I hope you understood the case study, and you had fun answering this case study. And this is what polynomial regression is all about. I want you to take some other one independent variable and one dependent variable data, and use the polynomial regression and practice it as much as possible, so you know what is happening. But if anything was in here you did not understand, feel free to text me, and I'll be more than happy to help you out with it. Thank you so much, guys, for watching this video. Meet you again in the next video. Thank you.